All right, hello, welcome everyone, and thank you for joining us for this live stream. Today's topic is running generative AI and large language models, otherwise known as LLMs, on a Kubernetes cluster. I'm your host, Michael Banta. I am the VP of Product at Cloud Institute. If you're not familiar with Cloud Institute, we are a cloud and AI training and coaching company that equips IT teams to confidently deliver on IT projects. We offer personalized coaching with cloud experts, AI practitioners, and hands-on project-based training to help you with your live projects. And speaking of experts, I'm thrilled to introduce Stuart Feeser, who will be presenting today. Stuart has been in the data and telecommunications industry for the past 35 years. He founded Alta3 Research in 1997, which is dedicated to delivering training and consulting services based on the company's research. He has written various courses on topics including Kubernetes administration and troubleshooting, Ansible Essentials, 5G Essentials, Certified OpenStack Administrator, and a ton more. Before I turn it over to Stuart, I want to encourage you to ask questions in the comments and we'll answer them at the end of the presentation. Also, this recording will be available here on this LinkedIn event page immediately after this live stream. We'll try to keep this around 30 minutes, and without further ado, I will turn it over to Stuart.
Thank you. Hi, everyone. You're here to learn how to run artificial intelligence on a Kubernetes cluster. I can promise you, ultimately, that is the way you will do it. But I'm going to treat this presentation the way that I wish I was treated just entering into the AI world, ready to run it on Kubernetes. So let's start from that perspective. The first lesson that I wished I would have learned is that everything that I know about storage is wrong. Imagine my confusion when I'm expected to understand that somehow 1.5 petabytes of data fits on an 80 gig drive in a Kubernetes persistent volume. There's just something about that doesn't ring true at all. I wish that would have been my head first. So with that in mind, let's continue. In generative AI, there's always a prompt. Now, if you've played around with ChatGPT, you'll know that you type in a prompt, something like this. And you'll see that the green part right here is just a storyline that I started. You then hit the enter key, right? And the information is passed into a thing called a transformer model. So let's just stop it right there. So what initially was passed in was this much, the green stuff, and that this little arrow lights up saying, I'm pushing that in. And the results that came back was as. No kidding. So then what happens next is all of this content now, the existing context plus the word as is then pushed into the transformer. At that point, the transformer decides, okay, the next word is going to be the. Now, you have to understand, it didn't know that until it calculated as. So the transformer has no idea how this story is going to unfold. It's just doing math. What is the most likely token? That's the proper word to use instead of word. What is the proper token that I'm going to calculate and then plunk that down next? So you're seeing the process right now. Why it's called generative AI is it's cranking out this output, which interestingly enough reads with some common sense. This process of constantly feeding the information in, getting results back, known as inference, and it is the transformer model that by far does it the best. All right, so let's keep charging. So regarding this transformer model, you need to add that to your vocabulary. And there were a lot of models prior to then. In 1980s, recurrent neural networks, then long short-term LSTMs and GRUs and so on. These are gone. Actually, they're still covered. There's some MIT advanced stuff that's covering this. You see it in other training classes. Guys, don't waste your time on that. In 2017, the transformer model completely replaced all of them. But 2017 feels like a long time ago. What took so long? And that would actually be a good question. And it was in 2020, this paper called Scaling Laws for Neural Language Models produced a river of money. And what this paper said is something that you need to understand as a DevOps engineer. This needs to be crystal clear to you. Number one, compute. I see a straight line going down. Now, normally downhill's not a good thing, right? Well, in this case, it is, because that downhill slope means less loss. In artificial intelligence, less loss means more accurate responses. So the less loss, or the less falsehoods we're getting back, the better. And I'm seeing, wait a minute, there is a relationship between the accuracy of the responses and how much compute, that's how much equipment I rack up. That's a straight line. So if you give me more money and I buy more stuff, the quality gets better. There's not a CEO on the planet that doesn't understand that. That's a good thing. But that's only one down, two more to go. The next thing is training. So this is the information that's actually pushed into the neural net. So that when I say training, let's just skip back all the way back to here and say that 1.5 petabytes of data. Yeah, that's the training. And we need to push that into the neural network. And we observe the better job we do, that's straight line. When in the financial world is there a correlation that's that clear? If I increase the data size, the training data, and I increase the compute, I get a more intelligent machine. One more. This is probably the hardest one to understand, and this is a thing called parameters. So let's take a look at what that means. So if you remember back in our school days, we learned about a neuron, and we knew that dendrites connected to other upstream neurons, and there's an axon that connects the nerve endings that ultimately ripples back through our brain, right? This is an actual living neuron. This is the artificial replacement. And right away, you should see some similarities. I noticed in this case, there's only 4 incomes. Now, in inputs. Now, in reality, that number's probably more like 10 million, right? So it's not just 4, but this is PowerPoint, and I had to scale this to fit on the screen. And we observed that it fits into weights. In this case, it's 4 weights. These weights are the parameters. A bit on that in a minute. The summation function and then the bias actually applies a value to the action function that decides whether we trigger the next neuron or not. So why do I have to know about parameters, and why is this so important in the river of money, right? Well, if I increase the amount of weights, this is actually where the data is stored. Now, it goes into the world of rocket science to explain that, but ultimately, these weights could be a 16-bit floating point number. They could actually be integers these days, but that's where the data is actually stored. And the more weights, the better. In fact, a typical example of a transformer model that produces really well would have 10 million rows of these. So you have to picture 10 million rows going down through, and then 400 columns in deep learning, 400 columns wide, or a total of 40 billion parameters. And again, we have a linear example. So this is almost too easy. If I increase the number of parameters, which only needs a few hundred lines of code to actually do that, that's not hard. And I have enough compute power to load all those parameters, and I put the right kind of training into it, I can build ChatGPT. And the answer is yes, you absolutely can. So please keep that in mind. Compute, training, and parameters. While the parameters might be the hardest to understand, by far the most expensive is the training. You want to keep that in mind as well. So let's go back to the attention process, or how a transformer will do a thing called inference. So I gave you this little example that I just typed in, sort of with an Orwellian flavor to it in the striking 13. And the transformer started inferencing. So it said, okay, the next word should be as. How did it determine that? Well, it just looked at the whole phrase, and in its 1.5 petabytes of information, it said, well, based on what I've seen here, the next logical token for me to use is as, and followed that, the. And the uncanny tolling unquestionably was selected because striking 13 is uncanny. Clocks don't normally do that. And I just paint it back through, as you could see that the selection of each one of these tokens was based on what was fed in, including what just actually was produced by the inference engine. So when you hear this term inference, which you'll see in some Kubernetes diagrams, that simply means the processing of the prompt and getting information to come back. The work involved in inferencing is much less than the work involved in training. All right, so let's get real on this notion of training. And ultimately, I kind of want to convince you here that doing this is pretty much a waste of time. And I'm going to show you why. So let's say that we had the mojo to gather up 1.5 petabytes of data. We actually did that, which is not trivial. That's millions of dollars, because you got to get the right data. You don't want to teach your model bad stuff. You want to be a good parent in raising your little kid over here. There are a lot of data sets that are downloadable. We can supply you that link. That gets requested a lot, right? And since we're doing training, this is the time to get the most powerful GPUs that you can potentially afford. The NVIDIA H100, the 80 gig and even 100 gig ones are in the $30,000 to $40,000 a piece range. Yeah, it's really expensive, but training is a lot of work, and arguably the most work. But the results, after many weeks or arguably months of time, we wind up with a fully trained model. But let's move on, because I already said, don't do that. Let's consider actually downloading a pre-trained model. And if you're going to research it, then go straight to Hugging Face. I know, funny name, Hugging Face, but that's the place to go. And we'll supply the link on that one. But on the leaderboard of the pre-trained models. So here you go, just download in this case, what was the number? 40 billion parameters. That was very expensive to produce that. And you can download it for free. And why is it the number one on the leaderboard list with Hugging Face? Well, here's the reason why. If we look at these 4 parameters, which are then averaged, right, you'll see that ARC stands for 25 grade school questions were fired at the model, and then 10 common sense inference questions, 5 multitask questions. My favorite one is how many lies have been shielded from the training process. You know what that means, right? The internet is full of lots of wrong things, which are judged as falsehoods. And they need to be screened during the training process, because no model can tell the difference between what is right and what is wrong. Well, Hugging Face knows the classic things that are wrong out on the internet, and they just ask questions. And if the model comes back with the wrong answer, then it's, aha, whoever trained you left that falsehood get in your little brain, right? So the little brain, in this case, you focus right on that 40 billion parameters. That's a pretty beefy pre-trained model. You can certainly go up into the 65 billion range. And as a general rule, remember what we've learned just a couple slides back? The more parameters, the better. So if I have capacity to run 65 billion parameters, I should, but that's going to require a GPU that has the capacity to load basically 80 gig of RAM. And we already know that's a $40,000 GPU. So could I run this on an A100 that is considerably less? And the answer is actually yes. In fact, the top performing model of the pre-trained models is the Falcon 40B. Cool. All right. So if this makes sense to use pre-trained models, then why might you actually choose to do this? Why not just use ChatGPT, like everyone else does, just type into it? Here's why. Number one, the data that you want to train into your model, or even the queries, the prompts that you're sending in, are sensitive and confidential, and you don't want to go in a public cloud for that. You want to customize your model to answer questions. That's called fine tuning. You want to fine tune it to serve your application. What's publicly available won't do that. You're going to have to fine tune it. The performance involved, yep, you can match up the right GPU with the right model, and you're not sharing that system or scheduling it with others. The result is actually tuned performance to what you expect. For me, this is the big one right here. Not that the others aren't important, but I want to protect my intellectual property. I don't want my content in artificial intelligence ultimately training other models. Because what's really interesting is that you can use a model to train other models and short circuit a lot of that effort in the training process. It's amazing to watch what's going on. The cost, actually the return on investment can be rather rapid if you know what you're doing. You're doing the right training work and return on investment. For us, our experience is way less than a year. It's more like 6 months for us. There was some school of hard knocks in being able to get it to that short, that's for sure. As far as offline functionality goes, I love it that I can store 1.5 petabytes of knowledge in an itty bitty little spot, and it's right there, it's right online. I'm not going out into the internet and looking stuff up. It's in my own model that is trained with all the stuff that I need it to do. So those and others would be the compelling reasons why you might want to do this on your own, which I'm predicting pretty much everyone's going to want to do this on their own. So that means fine-tuning a pre-trained model is in your future, and it's going to be part of your Kubernetes pipeline. So just write that down in your book. You're going to do it. So what is a pre-trained model? I showed you from Hugging Face. There's a 40 billion model. Now I put 30 right here because I happen to have some numbers that actually support that, because that was the cool thing when I was actually benchmarking this stuff. So here's what I've learned. When you're doing the training data in order to push it into a pre-trained model, because I want it to learn my stuff, the rules of thumb are right here. Number one, if that's less than 50K, you're actually hurting the model, not helping it. 100K, if it's a 13 billion parameter model, 100K is barely enough. Remember, the more data, the better. And if you're going into a 65 billion model, which means you have a really expensive GPU, you need 100 million, or you need 1 million data rows in order to train it. If you go less than that, you'll actually train it on the specific answers as opposed to more general intelligent answers. It's known as overfitting. So a lot of data is essential to pull this off. Bottom line, if you read this better or worse, if the parameters are less accurate, but there are, a bigger number right there, the better off you're going to be. All right, so we expect that we are now going to download a pre-trained model, train it, and in overnight to a week, I now have a model that knows how to run my business. And that takes us then to the last section here in this talk, which is, all right, I'm ready to take this to scale. Am I going to use Kubeflow, or am I going to use Tensorflow? They're both good, and they're both effective. Well, The Kubeflow is definitely batteries included machine language framework. But it's important that you understand, if you weren't aware of all that stuff that I just taught you, then this is not the question you should be asking right now. If you're at that point where, hey, this is cool, I want to start to examine how to use pre-trained models, I want to see how much work that is to do that, then don't get into the Kubeflow pipeline, which is very cool, but you don't want to do that yet. You want to actually master the process of selecting the problem you want to solve, select the right model, select the right hardware, and then the pre-training data that's going to be required to do that, and develop all those skills and get so good at that that you wear the fingerprints off you say to yourself, I am sick and tired of typing all this stuff where I take, for instance, a bunch of data and then I'm going to feed it into a training mechanism, take the results of that, and then copy that up into a model, and then have the scheduler manage that so that when some subscriber comes in, they'll right here, they'll hit the HTTP query, which then hits the inference engine. Yeah. So the truth is that all these containers, which are connected to appropriate GPUs, certainly stuff you can do manually, actually stuff you can do quite easily manually if you're just in test mode. But after you've done that about the 10th or 20th or the 100th time, I never again. You say, that's it. I'm sick and tired of typing the same stuff over and over again. You want to look for a pipeline, because at that point, you know the models that you want to use, and it's not going to be one. You're going to rack up a bunch of pre-trained models, and you're going to collect the data that you want to use in order to train them. And as time goes on, this information becomes so unwieldy that it's just too hard to manage on your own, and it's time to take a look at a pipeline. And I just ran out of time here. So let me just simply say, Kubeflow is the ultimate in batteries included. If you like the Tensorflow, I really have no preference. Quite frankly, I would write my own anyhow. So the Tensorflow, if you chose to go that way, that's the Google approach. You're going to run it on Kubernetes anyhow. So I think I'll wrap up this talk simply by saying, AI in your future, then Kubernetes is also in the future. You'll need a CCAD and probably a CKA to really excel at this. Don't miss the opportunity to study generative AI and to learn the process in order to do that. So we have some information actually coming up with an excellent link on how to obtain that training. We have a course specifically written to address that.
Amazing. Very informative, very entertaining. This is really incredible stuff. And again, just goes to show that although it can be expensive, all of this does not need to be nearly as expensive as all those H100 chips at 40 grand a pop.
For sure.
Which is something that always blew my mind. All right, well, we'll go to some questions now. And the first question from Jenny: cloud providers like Azure OpenAI and Google Cloud claim they'll never use customers' data to train their foundational model. Is this true, Stu?
So I'm going to answer it this way. I can justify not going that way because I like hardware. I like writing all the software involved to make it all work, and we will run it on our own hardware. That, however, doesn't mean that I don't hesitate to use one of the players out there maybe to do some training. But in these kind of talks, you really want my opinion. I would not use a cloud provider for this. There's too much compelling reason for me that I want to keep this close to the vest. If I'm a bank or something like that, there's just no way I want my data outside of my data center.
Makes perfect sense. Absolutely. All right. Next question. Would it make sense to have 2 GPUs and save money? From Courtney.
Yes, it would. So keep in mind that the inference process does not require near the GPU that the training process does. And also, you have to study a thing called quantizing, which means you might have 40 billion parameters, but there's no reason that each one of those parameters has to be 2 bytes or more. That can be reduced to 2 bits. So the smaller that you can make that package, the less of a GPU you're going to need to actually do the processing. And a lot of those skills are being developed right now. And that's one of the things actually we cover is a thing called quantizing. So you want to study that.
Always smart. All right. Another question. Are there any prerequisites I should have before I start taking AI courses?
It depends on the depth of understanding that you want. There are some really good basic level courses just out on the internet that cover some of the basics in the math. But we realize that for most people asking that kind of question, you don't have time to click around the internet a million different times to try to find stuff. And a lot of the stuff that's out there conflicts with other stories, and you can tell it's just old or outdated or some just flat wrong. So I think what we should do is share a 4-day generative AI class that we could offer that actually you could come into that one cold. And when you leave, you'll be able to do all of this stuff. Now, we don't hit the math real hard because we find that people don't want to know that. They just, what practical stuff do I need to understand in order to make this work? Some of the stuff out on the net that deals with the math is actually pretty good.
Makes a lot of sense. I'm sure people can search for their own on the math part, but then we can stick to helping them on
the practical.
The practical items. Yeah, good point. Good point. All right, I don't see any more questions, so let me jump to a quick offer we have for the folks that are here watching the live stream. So as you know, Stuart, being the CEO and founder of Alta3 Research, provides some fantastic training courses specifically around what we covered today. And we have 2 upcoming training events to keep you, your business, ahead of the AI curve, makes you understand all this fluently and at a deeper level. It's developed by Stuart and his team, and we're currently offering each course at a 33% discount, which makes each of those 2-day courses just $998. You can learn more at the link we just put in the chat. So you can see it there in the chat. Be sure to check that out. Click it, copy and paste it, and you'll be able to get a very large discount off either one of those AI courses. And if you're not quite sure where to start, that's okay. We strongly advise getting advice from a personal cloud coach, and that's something that Cloud Institute offers. If you subscribe to monthly or annual coaching, you also get access to our full library of training and hands-on labs at no additional cost. And that's over 1,200 labs and hundreds of courses. And coaching just starts at $64 a month. So you're welcome to start with either of our coaching subscriptions, monthly or annually. So that's the way to go if you're serious about advancing your career or your team at any particular business, is getting a personal coach to help them provide a personalized structure and path for you. Again, I guess thank you everyone for coming. Stuart, any final thoughts or insights before we close out?
No, I actually think that was pretty good. Thank you all for attending.
Yes, ditto. Thank you very much. And please do send us a message if you'd like to be notified of other upcoming events, and we can add you to that notification list. We will be hosting several more free trainings over the coming months about this topic specifically, about AI, and Stuart and his team are going to be a part of that since they are the best. And definitely stay tuned. In fact, our next event will be a Q&A on cloud security with cybersecurity expert John Hammond, and it will take place on July 26th at noon Eastern time. So I hope you guys can join us for that. Stuart, thank you so much for presenting today, and to everyone out there watching and listening, both live and those in the recording. Really appreciate your time and attention. Please let us know if you have any questions or feedback, and happy to engage with y'all. Stay tuned. We'll be around with a lot more content and live streams in the coming weeks. Thank you, everyone.
Bye, everyone.